All right, good day everyone. So now we're going to look at something called the triangle of forces. So there's a definition here, and the definition says that if three forces are acting on a body in equilibrium, then any triangle which has its sides parallel, that's a very important keyword there, to the lines of action of the three forces, taken in order, there's another keyword, in order, have the lengths of those sides proportional to the magnitude of the forces. All right, so let's see what this definition means in practice. So we have a worked example, and I've transferred it to the graph paper. Okay, and I'm not going to read it. I'm just going to show you what's happening here. All right, so we have a wall over here, and there's a rope. So think of this rope as hanging down over here, and there's a force connected to it of 2 kilograms, and that force is obviously hanging down here. Now what they do is they, somewhere along this rope, they apply another force that pulls it up. Okay, so it pushes, so the force is acting in that direction. And so now just think of the rope hanging like this. It's hanging here, and because of the force acting here, it's pulling this rope to the side. So the rope's actually hanging like that. See that? So there's the rope hanging like that, and there's the force pulling it to the side, and it's connected to the wall up there. Okay, so what do we do? We want to work out the forces in these two vectors over here. Okay, so first of all, we going to take a scale. Okay, now the scale, you can choose any scale, and this is what sometimes people struggle with because they don't know what scale to use. Okay, so we know the force in this vector over here, so it's 2 kilograms of force down. Okay, and the scale I've chosen is 1 kilogram of force equals 20 millimeters. All right, you could take 1 kilogram of force equals 10 millimeters, but then the triangle you're going to draw is going to be very small. So you have to try and figure that out yourself, and that takes practice, because you're going to have to be able to estimate by looking at your piece of paper how big you want to draw this thing. So first of all, I'm going to draw this red force here that's acting down here. I'm going to draw that to scale. Okay, and remember, I don't know how much force is in this line. I don't know how much force is in that line. All I know is the angle of this one is 60 degrees to the wall. So if I take my protractor, there you go, then I know that that's 60 degrees. And I know this one here is acting horizontally, so it's at 90 degrees. So it's at 90 degrees to the force. That's all I know. And this one's acting down. Now, I'm going to draw the one that I do know, this 2 kilograms of force. I'm going to draw that to scale. So what I do is I've chosen 1 kilogram equals 20 millimeters. So therefore, I have 2 kilograms. So that means the first kilogram has to be, 20 millimeters? So there. And the second kilogram has to be another 20 millimeters. So there I have it. So I'm going to draw this 40 millimeters down. Okay, 40 millimeters down. So there is my 2 kilograms of force acting downwards. Sorry, it's out of camera there. So there it is. So that's 40 millimeters acting downwards. All right. Now, what I need to do next is, so let me zoom out so you can see what I'm doing here. Okay. So now what I'm going to do is I am going to transfer. So this one is to scale, right? I'm going to transfer the two unknown forces to this force here. And what I'm going to need for that is I am going to need my ruler, and I'm going to need one of these triangles. All right. So first of all, we're going to go in order. So this force, and this force. Remember, when you do these things, always make sure if you go in one direction, so this is anti-clockwise, keep going in anti-clockwise. If you're going to go clockwise, then go that force, that force, that force. All right, so let's transfer. So the first one that's quite easy is F. So we know that's horizontal. And we don't know how long it is. So you can see there, I've taken my ruler and I've put my triangle in line there, and now I can slide this down. You can see everything, anywhere I go down here now will be in parallel. And take note, this line is not, I didn't draw it in line, it's slightly off, but it's still in the same direction, and that doesn't matter. So again, let's transfer the blue force down. So I'm going to go there, and I'm going to move it all the way down to here, to the end of that force, and then I'm going to take my pencil and I'm going to make a line across, a soft line across, because I don't know how long that thing must be. I just know that this line now is in parallel with that line. Okay, so you can see there I've got my faint line there, and the next one now, so we've started here, we're going there, and then we're going to do this one. Okay, so let's see how I'm going to do this one now. So I'm going to have to do the page like this, and I'm going to put my ruler and my triangle like that, so you can see there, and I'm going to slide this. So you see it's in parallel. So anything down here now is in parallel. See that? Okay. Now, obviously, what I can just do now is I can just make a faint line like this. See that? So that line now is in parallel with that line. Okay. And all I need to do is extend it now. So you can see here. So there's my two lines. Again, this one is in parallel with that one. This one is in parallel with that one. And I'm just going to extend it now. So extend it, and you can see the two lines intersect. You see they intersect at that point. Okay, so I'm going to take my blue pen, and I'm going to draw that in blue, and that represents F. Okay, and then I'm going to take my black pen, and I'm going to go over that one there, and that represents T. And now I have my triangle of forces. So we know that this one is 2 kilograms of force acting down. This is F, and this is T. So what that definition is basically saying is, if I take, so I know that force there, and if I take the other two lines in parallel, see, I've transferred it down in parallel. I don't know how long it is. I've transferred that one down in parallel. I can measure these now, and they will be proportional, right, to this force here. So check here. If I measure that now, I'm going to get, let's see here. So this one I'm measuring approximately now, so don't worry, 72 millimeters. 72 millimeters. And this one I'm going to measure to be 80 millimeters. 80 millimeters, okay? And then all I need to do is take that. So there I've got 72 and 80. And I'm going to do the first one here, 72. 72 divided by 20, because 20 is my scale. And I'm going to get 3,6 kilograms of force. See, so in this F line here, there is the 3,6 kilograms of force. And in this one, I'm also going to divide that by 20 millimeters. So they I've divided this one also by 20 millimeters here. So you see that? So that's going to be 80 divided by 20, and I'm going to get 4 kilograms of force. And that's it. So now, by just transferring those down in parallel, we can calculate approximately what the force is. So again, you remember this is a construction, and you know, sometimes like the book here, they measured slightly less than me. So they got 3,5 kilograms of force. I got 3,6 kilograms of force. Over here, I got the same 4 kilograms of force. So that's not a big problem. Remember, we are doing this by construction. We need to try and do this as accurately as possible. Make sure your pencil is sharp, not like mine, and just do it carefully. All right. And you remember, if you took a different scale, if you took 1 kilogram of force equals 10 millimeters, your triangle would be a lot smaller. You'd have like the first one there, like that size. It'd be a lot smaller, and sometimes it'll be a lot less accurate because of that, because your scale is smaller, but you should get the same answer. So what you must do when you practice this, you draw this, and then you draw it to scale. Choose one scale. Then for practice, take a different scale. Maybe 1 kilogram of force equals 30 millimeters. Then you do the same thing. Your triangle will be bigger. And when you measure this, it'll be, these sizes will be longer, but then you divide it then by 30 millimeters. And then you should get the same answer. All right. Hope that helps.